All right, so we've been trying this practice problem, not too hard. I'm going to go to just the answer. Okay, you should stop talking and start listening more. So here we go. Here's your picture. Everyone have that? Like, it should be really easy to draw this. What's one thing you could for sure do wrong? Drawing the dot in the solvent. That'd be it. And then of course, yes, not draw it, but that's like asking a beauty queen what type of dog she likes. But whatever. That was so random. Like, hey, thanks. What kind of dog do you like? What kind of color do you like?
What is the color of the paintbrush?
That's true. I taught that kid and I love her to death. She is 1 in 10 trillion people. She's such a weird person. Like an athlete that doesn't give a crap. And like sort of smart, but doesn't care. And people could call her ugly and she just tell them to do something I can't say out loud. Like she was just, what are you playing? Because no one can pay attention to me.
I am paying attention. You said that.
Anyway, I loved like how just her she was. So if you ever worry like, I need to like be more like, no, you don't. You need to be more like yourself. Like people love you because you're an individual, not because you're someone else. And that girl like kind of knew that. Now, I don't know if I love that she told you all to just punch people, but whatever.
Oh, we're talking about that girl. I thought we were talking about some random.
Okay, you need to put the iPad away. Okay, here we go. I recorded that whole time. Oh well. Since the solvent, which is the mobile phase, why is it called the mobile phase? Because it moves. Like, it could be confusing, but it's common sense. The solvent, the mobile phase is slightly polar. The blue dye will be less attracted to it and more attracted to the paper. All right. How did we know that isopropyl alcohol was slightly polar? Does it say it in there? Okay. Okay, did you hear that? It doesn't tell you both of them, but it tells you stationary is what? Nonpolar. So the solvent isn't going to be another nonpolar typically. So it's probably the polar one. And alcohols, they have OH at the end, and OH makes them more polar. Now, the bigger the alcohol, the less polar, because then dispersion forces take over. But isopropyl alcohol is propyl, MEP. That's the OH. That got ugly at the end. Okay. Now, this is propyl alcohol. Iso means the structure is weird. It's like a triangle. So don't stress about it, like the iso part. It's an isomer, which you'll learn about if you ever take a chemistry class above this. But the alcohol makes it slightly polar. But if I have isohexa, it's going to be more and more nonpolar because this part of the molecule becomes more dominant than that part. But anyway, okay, coming back. The blue dye will be attracted to it and more attracted, or not, but more attracted to the stationary phase. The red dye is more polar and will be more attracted to the solvent than the paper. The red dye will travel the farthest. Are you all right reasoning through that? Okay. Okay. This thing here, this is extremely, extremely rare on the test. As in, I haven't ever seen it on the test. But I've also only given one test since the new rewrite. And I'm just going to tell you how bad of a teacher I am. I haven't even looked at the test. I can't see the multiple choice. That's not released. They release one multiple choice every 7 years. The free response, they release it every year. And I should go look, I guess. But here we go. We have been doing paper chromatography. We've been talking about it. You okay with that? This is called Coulomb chromatography. And it's sort of the same idea. You let things travel through a medium and it separates them. But the big one, and I made it all caps, is the word and. Coulomb chromatography is useful in separating and then collecting a solution in its parts. Okay, so it's sort of complicated, but not that bad. What you have a mobile phase, which is the stuff that'll go through. Like it's just a solvent. Okay, then you typically have this silica gel that the stuff will go through due to gravity, the sample. Okay, but depending on its intermolecular forces and attractions, the things that are more attracted to whatever your mobile phase is, solvent, due to gravity, will travel through faster, and the thing that are least travel through slowest. Anyone with me so far? Okay, this is like the gel is like a sludge. You put your sample on, you put a mobile phase on that will go through the sludge, or like pouring water through sand. You okay with that? So sort of. And then the sample's here, and as it goes through, it takes the things with it, but they move at a slower rate based on their attraction to the gel versus the sample. It's upside down. But here's the value in this. This stuff will travel to the bottom. Now the scribbles here, this is just like cotton or glass, like filter. What do they call it? I can't remember, but it's just the stuff there to help the silica gel not go into the valve. That's all it is. But once the green gets to the bottom, oh, I need to tell you something. That you open this valve and drain the liquid out. You probably figured that out, but maybe someone didn't. Once you have drained it to where the green layer is, then you move your beaker and you collect the green and you move it out. And then you move it and you collect the orange, then the blue, purple, and black. So you can end up with actual, oh, did I not ever cut it? Maybe it's lower. Oh yeah, it is. So you have this thing called the eluate, that's just the garbage. That's just the stuff that filtered through. But then you have your separate things. And now you could analyze these to determine what the original solution had in it. Okay, now you don't have to know much. You need to for sure understand why things travel. It's because of their attraction or non-attraction to the solvent. You need to know that paper chromatography, the stuff moves up if it's more attracted to the mobile phase, and it moves less if it's more attracted to the stationary phase. And then the opposite for Coulomb. But you need to definitely know, no, I guess it was the same for Coulomb, but it's just going down, that paper chromatography is just to determine what's in there. Like, hey, it's made out of these pieces, and good. It's like combustion analysis. We don't get the stuff back out. We lit it on fire to find out what was in there. We're not collecting it. Paper, we use it to figure it out. If we use Coulomb, we're trying to figure it out and to collect it. You all right with that? So there's a question. I thought I cut it, but it's nowhere to be found. Let me go in and cut and paste this question from the AP practice. All right, here we go. This is These type of questions are more and more common on the AP test. And it's, remember how the other day I said, like, people from the 90s think we're all wusses. They would look at this and be like, you're kidding me. Like, they used the Pythagorean theorem. No. What's the other one we do? Quadratic equations. We used to have to do quadratic equations on the AP test. And now you're telling me which picture looks cuter. Seriously. Sorry. And you used to have to be able to use matrices to balance complex reactions.
I learned those, but I don't remember how anymore.
Okay, but anyway, I didn't have to, so I didn't. I just know they used to have to. Okay, here we ready? A student obtains a liquid sample of green food coloring that is known to contain a mixture of two solid pigments, one blue and one yellow, dissolved in an aqueous solution. Okay, time out. The word solution is important. The word solution already does something to what you can see on the screen. What does it do? If it's a solution, what does it tell you about A? It is not A. What is this process called? Filtration, which we can use for mixtures, but not solutions. Now you got to be careful. A solution is a mixture, but not all mixtures are solutions. Trail mix, mixture. Kool-Aid, mixture. Kool-Aid, solution. Trail mix, not solution. You're right. I just feel like I was teaching like English or something like that. Repeat. All right. Okay, so we know this one's wrong. Okay, next. Which of the following lab setups is most appropriate for the student to use? All right, so A is filtration. We know it's out because it's a solution. All right, B is what? What do we call B? Yeah, it starts with a D. Distillation. All right, and it is used to separate things based on their boiling points. And if this gave me any information about boiling points, the question would be a little bit trickier, but it has nothing to do with their boiling points. Are we okay with that? So if it was distillation, it would say like the blue has a boiling point of 28 degrees and the other one's 50 or something like that. You would need that information to know it's a distillation problem. Okay, so really it's a battle between paper chromatography and column chromatography. So let's look back. Go ahead, Aislinn. Well, that's okay. Let's look back and read it one more time. To use in order to separate and collect. If it just said separate, like our minds would explode because it'd have to be both answers, right? But the and collect makes it so D has to be the right answer. Okay, we have our porous medium. This one's just a really short one. We have our alluate, which is just our mobile phase or our solvent. We have our sample that flows through, we separate it out. You okay with that? The key word, if they're testing between paper and column, is that you can collect it. Okay. The other part, the last part is called thin layer chromatography or thin paper. And thin layer, we're not going to spend any time on it. It's just like paper chromatography, except it's typically horizontal. You have a surface, you put like a droplet on here, just like the COVID test we were talking about. You put it on this thin layer and it is absorbed by this layer, and then just that capillary action pulls it through. And it works for things that are a lot smaller that you don't want gravity to have any effect on. I don't know, there's not a ton of details on thin layer, so I would not stress about it, but you don't put it in a beaker and soak it. It's just a flat thing. You put it on there and you see how it disperses through. And once again, if it's attracted to the mobile phase, it goes far. If it's attracted to the stationary phase, it doesn't. Go ahead. What's that? Yes, I have one planned for you, but it will be after the exam if it shows up. I've ordered it. Anyone ordered anything lately? So who knows? Yes, we can do M&Ms if it doesn't show up by Monday or Tuesday. But yeah, I ordered one and hopefully it shows up. Okay. Look at this. What is all this stuff? Math. Which, no? Oh, yes. Enjoy.
I don't do it.
Wait, we've done this before.
Okay. How do you feel about it? You got it? Okay. Should I, I'm going to ask you a question. If you can do this, do it on paper, then it's good enough. How, now this is complicated. How would you, whoa, that was weird. My eyes are just trained for seeing the word Kylie Hadfield and go back to pole. That's all I've read for 3 straight days. How would you make 300 milliliters of a 0.5 molar NaOH solution? Okay, if you can figure that out, then that's like the only thing. We didn't really talk about making them. We've always had them and been with moles and all that. But how would you like literally yourself make this solution? Now I feel bad. I took the calculators from the back. You guys, can you breathe? Everything all right back there? I don't know what happened, but there's some red faces on some red heads right there. Nope. No Pivnert. There it is. All right. I'm looking for a sentence, not a number. Because, like, how do you build a house in Manaway? 600,000. Like, okay, but like, how? Like, oh, give someone $600,000 that knows what they're doing and wait a year and a half. Interesting, or more now, yeah. Okay, we ready? So we got a beaker and it's 0.3 liters, right? And I want this to be 0.5 moles per liter. So how many moles do I need? I need 0.15, right? The necessary moles to make this is 0.15. Now, you can, and we had this discussion, you could technically say add 0.15 moles of sodium hydroxide to whatever, but I don't have a scale in the back that measures moles. I think it'd be a genius thing. You type in the formula and then you just pour in, it gives you the moles. Huh? It probably exists. But anyway, moving on. We don't have one. So we should probably convert this to things that I can measure, which would be grams. So how do I take moles and convert it to grams? All right. I don't know. I think I heard the word divide, but I don't think I would do that. For every, now this is a backwards picket fence. It will feel wrong in every way that is holy, but whatever. This says moles, right? So I need 1 mole on the bottom, and was it 44? Was that right? Oh, 40. Okay. 40 grams. And that will tell me what? You need 6 grams. Now that's not your answer. And in AP, and I don't know if I've talked about it before because I remember talking about it, but that could be a year ago. You need to very specifically answer this question. Are you ready? You would say, add 6 grams of sodium hydroxide. And this is where it gets technical. You cannot just say to 300 milliliters. That you'll get it wrong. Because by adding those, that would change the volume, which would change the molarity, right? It's dumb, but you say add 6 grams of NaOH to enough water to make 300 milliliters of solution. You see the subtle difference? Now, a lot of you in here will probably have a child. When you have that child, you're going to have to feed it. Okay? That's when it sucks. Like, oh, it's cute. Then you're like, oh, I got to pay $200 a month for formula? Yeah, you do. All right. Now, the formula instructions tell you to basically do this. They tell you to put the powder in and then add to like the 3 milliliter mark. But what does a cheap dad do? Fills it to the 3 milliliter mark, then adds the powder, and now they're eating 5 milliliters. Ah, I saved 40%. That's not math. That's not math. 66%. No, that's not math either. 60%, I think. It's got to be. It was 40? Okay, either way. Now I know it harmed my children. They're both tiny individuals. Wait a minute. But you'll, like, one of you maybe will remember this some night when you're in the middle of the night, like shaking a bottle, like, oh, I'm cheating my own child. Davidson warned me, but I don't care. Eat it. Stop crying. I need to work. Okay. Now, I will go on the record. My kids are very strong, big, and healthy, so I don't think it really ruined their lives. Okay. What? No. That's the thing about parenting and teaching, by the way. I literally have no way to prove I improved your life. How do I know it wouldn't have been better by someone else? I can't prove it. What? It is. Coaching is the worst. Like, it's kind of like a doctor. You should do no harm, but how do you know? Like, I've gone to clinics and all this, but what if Timmy with a better coach is running 52s? And here I am, just his anchor holding him back at 54, 3. Tim is an enigma. He is an enigma. He throws jab. He does cross country. He runs the 400, and sometimes he sprints in pants.
One time.
But one time is one time too many. Like, you did. My kids were PO'd. Not my kids. Derek was. It's like, I lost to a kid in pants. Like, Derek, you're slow. I hate to tell you, but okay. How about I tell you what's on the test? Would you like the 2018, the 2017, or the Chapter 11, 13, 2001 exam free response only, or the 11th, 13 final 2019 easier test? You don't want a challenge?
I want one that's like up to date.
The most up to date is probably the 2020 with variables. This was like I can't remember, some French word, like my masterpiece. What is it? Oh well. What word? Did you know it? All right. In 2020, I was worried about kids cheating. You don't need to write this down because it's not on there anymore. You probably still cheat, but I just have given up, maybe. I don't know. But I changed this test. Everyone got a test, and then I just handed out a bunch of slips that had A, B, C, D, E, F. And you had to write what slip you had, and then that was your answer. Like, you had to use those variables, and everyone got different answers.
So I could have just written down really easy numbers.
You, me?
I could.
No, because on your test, you wrote down what version of the slip I gave you, and it had to match those. All right. But luckily for you, you don't have to calculate the mole fraction, which is easy. B was the very hard part. You don't have to do that. But let's look at stuff that you do. Okay. I'm not going to answer these, but I'm going to tell you there will be more than what I'm showing you because I'm getting rid of the math, which means I'm going to add probably some picture crap where you draw stuff out. You with me? And some more conceptual. Definitely, there's no chromatography on this version, but there will 100% be chromatography on the real version. Okay, here we go. We've had this exact stem before. Use the concepts of chemical bonding and our intermolecular forces to account for each of the following observations. Okay, you haven't had that specific word, intermolecular forces. But this is common. I give you a statement that's true, and you have to justify it. Does that sound familiar? We've done that on 3 specific tests. The boiling point of water, propane, and methane are those things. You may remember we went over that exact type of question before. What is happening here? That's your femur, all right? James, I love you. How's 3rd East? Okay. He's my backyard neighbor. I don't really know. Okay, there we go. That was a mediocre, like acetabular, wasn't it? Never mind. It's your hip and your socket. I'm moving on.
Definitely tell it. That might be what your hip looks like. I don't necessarily give you.
It is Hope Day. I should leave this room feeling amazing about myself. I did.
You matter. Corbin just now.
Oh no, where is it? Oh, I still had her. All right, we ready? Have you seen B before? Yeah, you've seen it exactly before. Have you seen C before? Yeah, you did in chapter 8 or 7. That exact question has been on a test before. Because I love you. What's that? The concept of C, is it C? Yeah. We talked about not Isabel Higgs or Kylie Hadfield. Those are the only two names stuck in my head. We talked about, oh my gosh, Coulomb's law 10 million times. 10 million times. If you don't know what I'm saying, you should look up why that has to do anything with Coulomb's law. And there's a specific term that I'm not going to say out loud as to why one has a higher melting point than the other. Now, it's not from chapter 11. It's not an ion dipole. It's not a dipole-dipole. It's not a dipole-induced dipole. It's not a London dispersion force. It's not a hydrogen bond. It's something from another chapter that I know someone knows in here. Nod your head if you know the words I'm thinking of. It's 2 words. I got 1 person, 2 people, 3 people, 4, 5 people, 6 people, 7 people more.
No, just because we move our head, we're nodding.
We're all going.
I'm not saying it, but if you don't use the term I'm talking about, you're not going to get this one full credit.
Somebody say what it is.
No, not in front of me.
A chemistry word. Turn around. Somebody said it
Oh.
on the group chat.
I have no control what happens on group chats. And you guys have done me a huge favor. You voted 20 million times for something that doesn't even matter. So if someone wants to put it on the group chat, I'm not going to complain about it. Oh, I thought you did it to support me as a human. Kylie,
Yes, Kylie.
box elder, and really cookies. Okay. Letter E has absolutely nothing to do with really anything we've talked about this chapter, but it's so easy. What? Oh, that was satisfying. No, you did it. You were good. Oh, hey,
Try.
a drawing.
Whoa, what we're supposed to do. Oh, yeah, we did.
I was prepared. All right, here we go.
That is true.
Ooh. What's IMF stand for? Intermolecular forces. It's the forces between like molecules, essentially. Oh, we did this in the notes. No, I'll just do the test on the screen in front of all of you with this new tool I've never used. Let's go this color. What? I swear I'm so.
The black one, it's a galaxy one.
It's fantastic. That was not to you. That was to a previous question. But your mom's amazing too. Thank you, James.
Is that you weren't gonna tell us? The answer is. I figured it out, guys.
I just lied to a kid in my ward. It was good though. Now I hadn't tasted it yet. It's hard for me to talk after I eat ice cream. You know, like you get gooey, like nah, like you'll never see me at the basketball game with like a chocolate milk or a shake because you'll be like, make them. I'm hoping I don't screw up as many names tonight. If anyone paid attention last game, I struggle. I gave a kid a 3-pointer that graduated 16 years ago. I called Serena Meekum. And this one shouldn't even count. I called Ashlyn White, Ashlyn Reeder. There's 3 Ashlands on the same basketball team. And that's on them. I mean, change your names. Okay. All right. Your mom. The answer to this one is cool. I actually like this pen. I wonder what my signature looks like. Ooh.
Wait, what's your signature? Tom Davidson.
That looks like a skateboard.
It's there. Right here. OMDAVIDSON. Right here. And not the I. This one's closer to my actual name. Let's see here.
Now we can forge your signature.
2, 2, 1, 2.
No, he's posting this.
All right. It's not hard. I don't care. I tell my own sons to forge my signature. This is how I tell them to forge my signature. Are you ready?
Okay.
I say, that's not, nope. I tell my sons, put the number 2 with a long tail. Whoops. Hold on, I gotta fix this. Okay, come on. There we go. Okay, so the number 2 with a long tail. That's Tom. Everyone ready? Then I just tell them to write like die, sort of stretched out. It's hard for me to forge my own signature. But if you write a 2 in the word die, it kind of looks like my signature. So 2 die. Nope. Your first one was close. Okay, moving on. Shh. I should talk more about the test. Oh, that was it. Was that it? There's no way. Oh. You're going to have to pause that video real fast. That's doable. You just voted 60,000 times. I know you know how to pause a video. It was like I can't even function. Okay,